Acids and Bases Part 5, where we'll be looking at past paper examples and all different types of questions. The first one reads, two acids, HX and HY of equal concentrations are compared. The pH of HX is 2,7 and the pH of HY is 0,7. Which acid, HX or HY, is stronger? Give a reason for the answer. So 1 is 2,7 and 2 is 0,7. Now I want you to think of the pH scale. Closer to 0, the more stronger an acid is. Thus, Hy would be the answer because it's a lower pH. The next question. Learners add 150 centimeters cubed of sodium hydroxide solution, NaOH, of unknown concentration to 200 centimeters cubed of 0,0 mole decimeters cubed hydrochloric acid solution, HCl, as illustrated below. They find the pH of the final solution is 2. Assume the volumes are additive. So here's the NaOH and here's the HCl. Here's the final solution with the pH of 2. The balanced equation for the reaction is given. Right. First question. What is the concentration of the H3O plus ions in the final solution? So you have the pH, you just need to work out the concentration. The formula is 10 to the negative pH. So 10 to the negative pH, 2, which will give you 1 times 10 to the 2 mole decimeters cubed, or 0,01. Now you have the concentration. The next question reads, the initial concentration of the NaOH, which is this. Now you need to find out what the excess and limiting is. So we first work out the number of moles for the hydrochloric acid, CV. Now your C you just worked out in the previous question, and your V is the 150 plus the 200 because it is getting added together. So it would be 350 centimeters cubed. However, it's centimeters cubed, you need decimeters cubed, so you divide by 1,000 and you get 0,35. You have your answer here. Now you take the initial hydrochloric acid, which is 0,03, they given the concentration, and the 0,2, meaning the volume divided by 1,000, and you get this. Now you subtract the excess minus the initial, and you get 0,0025 moles. It's a 1-to-1 ratio, thus you use the same for both. And you take the number of moles and you say the 0,15 because they asked for the NaOH. NaOH is 150, just divided by 1,000, you get 0,15. And you get this. You need to follow it step by step to get the precise answer. Because if you mess up here, you're not going to get any precision marks. The next past paper example we'll be looking at is this one. They have given you the balanced equation, and the first question reads, is NH4 plus the conjugate acid or conjugate base of ammonia in the above reaction? This is ammonia. This is water, which is a base. If this is a base, this should be an acid. Thus, it's a conjugate acid. The next question. Write down a balanced equation to show the hydrolysis of the ammonium ions. Now, if you've watched my previous videos, you would instantly know the answer because I told you to by heart, and you would write this down. Next, during a reaction, 25 of an aqueous solution of strong base BaOH with a pH of 13,6 was added to 40 of an aqueous solution of sulfuric acid of the concentration 0,15. The following reaction takes place at 25 degrees. They have given you the balanced equation. The question reads, calculate the concentration of the BaOH solution used in the reaction. Now, you can either say 13,6, which is the power of 10, or you can do it this way. You have 13,6 as your pH. You need to solve for H3O+, but BaOH is a base, so you need to put it in the base formula and you solve for your OH ions. However, BaOH has a 2, thus you divide it by 2, so your 0,4 divided by 2 is 0,2, and that's your answer. The next question, calculate the concentration of the hydronium ions in the final solution, assuming that the volumes are additive. So, this part, everyone should aim to get full marks in. You have your concentration that you worked out, and they have given you the 25 as the volume. You just need to remember to divide by 1,000 or times by 10 to the negative 3 because you need the volume in decimeters cubed, and you get this as in your answer. The same thing for the H2SO4. However, they've given you the concentration and the volume. You didn't need to work out anything, and you've solved for your answer. Now, you work out how much H2SO4 is reacted. It's just a 0,05 because that is your limiting. And then you subtract 0,06 minus 0,05 to get what was in excess, 0,01. This is the tricky part. You first need to work out your concentration, which you use the excess. And you add the volumes. This is where everybody mixes it up. You add the 40 and the 25 to get the 65. And this is another part where everyone mixes up. In the previous videos, I told you if there's a H2, you always divide by 2 or times by 2, depending on the situation. And here there's a H2SO4, meaning H2, and in this case, you multiply by 2. This is where some of you may not get your marks, but you need to remember this because this will take you from a C to an A or B. Our last past paper example is this one, where they give you a balanced equation and the question reads, apart from water, which substance in the above equation can act as an alveolite? In the previous videos, I have mentioned it, so it should ring a bell. HSO4 could act as an acid or a base. The next question. A solution of hydrochloric acid has a concentration of 0,1 mole dot decimeters cubed. Calculate the pH of the solution. Hydrochloric acid is an acid, thus use the acid pH equation. And you solve, and it's 1. To know you're correct, you should know it's an acid. An acid leans between 0 and 6. Thus, if your answer is anywhere between there, it should be good. And to know you're 100% accurate, hydrochloric acid is a strong acid which should lean more to the 0 side. A flask contains 200 of an aqueous solution of sodium hydroxide of concentration 0,1. To this flask, 50 of an aqueous solution of barium hydroxide of unknown concentration is added, given a total volume of 250. In a titration, 20 centimeters cubed of this mixture is completely neutralized by 30 centimeters cubed of a hydraulic acid solution of the concentration of 0,1. Then they have given you a balanced reaction. The first question, what is the pH of the solution when the endpoint of the titration is reached? The titration only happens when there is neutralization, so it should be equal to 7. Calculate the number of moles of hydroxide ions present in 20 centimeters cubed of the mixture of sodium hydroxide and barium hydroxide solutions. You already have the concentration which they give it to you, 0,1, and you have the volume, 30, which You divide by 1,000 and it should give you 0.03. Now you have solved for the number of moles. The last question. Calculate the initial concentration of barium hydroxide solution that was added to the solution of sodium hydroxide. Now, in this case, you're working out how much is in this 250 centimeters cubed, the number of moles. So you have the 250 and you have the 0.03, which you just worked out, and the 20. The 20 being the volume of the titration mixture. And you come out to 0.375 moles. Then you work out the number of moles in the barium hydroxide. So you have your total minus what you had at the beginning. So you have your 0.075 minus the 0.02, which will give you 0.175. Then you half it because it's a 0.2, and then you just half the 0.175. And you take the halved amount and you divide it by 0.05, which is the 50 centimeters cubed, and you have your total amount. 50 because you're solving for the BaOH.